But basically, iSCSI is a protocol that's used on storage devices. So all the attacks that we talk about today are primarily around storage devices and how basically you can get access to large volumes of data, significant volumes of data from these storage devices that are left insecure. So here's the kind of the agenda for the next hour and 15 minutes. I'm going to be somewhat hopping around the slide deck. There is actually a new slide deck from the one that's in the big thick red book. So if you want to download that from the Black Hat site or from the iSCI partner site, you're welcome to do so. So here's a little bit about who we are. I'm not going to spend any time on it, but again, we are an information security consulting, research, and tools company out there. A couple of the presenters from iSEC talked this morning about web services. I specialize in storage security, primarily in fiber channel and NAS, and most recently iSCSI. Okay, so what is iSCSI? Well, the I stands for Internet Protocol, obviously, and SCSI stands for Small Computer Systems Interface. You put those together, and you get insecure SCSI. But seriously, what is iSCSI doing? Well, for the purpose of this presentation, it's the ability to access data blocks remotely over the network. So traditionally, those have been used in fiber channel SANs, where you have fiber channel HBAs, fiber channel switches, accessing data blocks. Well, the beauty of iSCSI, and why I think it's going to be very, very popular, is now you don't have to set up all this infrastructure using fiber channel, but you can do that over your regular IP network. And no, it doesn't have to be gigabit IP. Obviously, if it is gigabit IP, it's a lot faster, but it doesn't have to be. So you have this entity that can provide large data blocks, large disk drives over your regular IP network. So that Exchange server that's always running out of space can now be given 30 gigs, 300 gigs of data over the IP network without taking it down, without putting in another disk drive, without using any partition magic software to screw things up or anything like that. So storage capacity becomes a lot easier. There are inefficiencies using IP versus fiber channel, but again, using IP is a lot more flexible. So for those of you who do not know the difference between file and block level, I'm sure a lot of you already do, think of file level as CIFS, the NAS world, CIFS, NFS, and block level as the disk drive. A very simple example, but that's the example that we'll use for the presentation. So what is iSCSI used in terms of security? Well, a variety of things, but three basic things: authentication, authorization, and encryption. Now, the authentication that it uses is Chap. And you don't need me to tell you all the issues with Chap. It's well documented in a lot of white papers and a lot of research papers. Even in the RFC for iSCSI points out the weaknesses in Chap and why certain other things should be enabled. The biggest issue, which is a very simple issue, is that authentication is disabled by default on a variety of storage devices. So even if you have a storage device, you have to go in and manually turn on authentication because it is disabled by default. So why would anyone want to do that? Especially you connect to a network now, and you always have to authenticate in some way, shape, or form to get access to the internet, but yet people aren't authenticating their own storage devices that have their own sensitive data and their own confidential information. Well, usually the answer is ease of use. How easy is it to set up this storage device, plug and play, and get things going? Which is a very true statement. Having 13 or 14 clients authenticating to an iSCSI device is not necessarily easy to set up, but it's required if you're a security person. If you're coming at this from the security perspective, there should be no negotiation on authentication. But when you look at it, you're not talking to security people. You're talking to storage people who think about functionality, performance, uptime. That's the thing they live and die on. So when you talk about authentication, you start talking about things that are slowing down their process, the things that they do get paid for. So why should we care? Well, we should care because we're talking about large volumes of data. We're not talking about one table in a database, or we're not talking about one operating system. You're talking about clusters of data that support multiple operating systems, multiple databases. And they're out there on the network for someone to compromise if you have deployed iSCSI by default, in its default state. So what are some of the vendors saying about iSCSI security? So I put this quote up, and I thought it was very interesting. This kind of shows the gap between storage and security people. It basically says that you can't sniff or spoof or hijack an iSCSI communication unless you have physical access to the network. Now, you may or may not agree with this. My personal opinions aside, I definitely don't agree with this statement for a variety of reasons. But what it's actually saying is that your internal network is secure. So you have to trust your internal network, and if you do, you're ready to go with iSCSI. So if you do trust your internal network, you probably are ready for iSCSI, but if you don't trust those employees, those contractors, those consultants, those VPN users, wireless users, business partners, and whoever else is on the internal network, then maybe you want to look into iSCSI a bit further. But sometimes security professionals are forced to trust their internal network. We probably don't want to trust our internal network, but we don't have a choice. What other choice do we have? What can we actually do? Well, the fact is that iSCSI, or a lot of vendors will say, you know, there's nothing else you can do, so just plug and play, don't worry about authentication, because there's controls out there, there's firewalls out there. Well, maybe on the perimeter, but not internally, and most likely not internally. So if you deploy iSCSI in its default state, you're also agreeing to removing all the file permissions on your operating systems or your file servers, removing all, or allowing everyone to see everyone else's email, removing all the passwords from all your databases, allowing HR information to be out there for everyone to read, and telling those auditors that, you know what, those internal controls that you guys bug us about, we don't care about them, because we don't care about internal controls. So when you talk to your iSCSI vendor and they start saying, well, it's an internal issue, yeah, it is an internal issue. Now, it can be an external issue, but the fact is that I don't think anyone would agree to these 5 concepts around their storage data or any kind of data. So why should iSCSI, or why should any protocol, fiber channel NAS, kind of get the get out of jail free card, especially when it's holding a lot of data in block format? Okay, so quick definitions and terms for those of you who do not know a little bit about it. Some of you may not. Some of you may already know, so you can kind of skip over this section. An Scuzzy Initiator is an iSCSI client. An Iscsi Target is an iSCSI storage device appliance. I'm going to use those terms interchangeably, so hopefully I don't confuse anyone. And there's something called an ISNS server, a simple name server. What that is, for simplicity's sake, is a DNS server for storage devices. So you're going to have like hundreds of iSCSI clients and 30 iSCSI targets, and instead of having everyone like know where they should go to, use a simple name server, just like DNS. Instead of every operating system having a host file, you have a DNS server. Same thing for storage devices. You have a simple name server to kind of tell where everyone's at. There's something called an initiator node name. That is basically the identity value of a system on an iSCSI storage network. So it's like your MAC address. And just like your MAC address, it's spoofable, but unlike your MAC address, the iSCSI drivers, the clients, actually have a feature to change this. They actually want you and allow you to change this at any point in time. It's sniffable, so it's clear text, and it's brute forceable. So the unique ID that identifies you as an iSCSI client is vulnerable to a lot of common security issues. Domain sets are basically groups of iSCSI clients and targets on your simple name server. So you might have an Exchange domain set, a database domain set, Oracle domain set, kind of logically segmenting the iSCSI network by the use of an initiator node name. And we'll get to more into these. I'm just going over the terms right now. And LUNs, logical unit numbers, that's basically if you have a 400 gigabyte storage array, you can break that up into 4 100 gigabyte LUNs. So you can basically allocate your data from your storage device all over the network through different operating systems. Okay, so here's an iSCSI Initiator. Basically, it's a regular operating system with iSCSI software. And notice I did not say special hardware. Unlike Fibre Channel, you do not need any special hardware to be an iSCSI client. You just download a driver. You can download it from Microsoft, HP, Cisco, IBM, there are a variety of places. And you put that on your laptop, your desktop, your server operating system, and instantly it's an iSCSI client. And you have access to iSCSI targets. So you don't need any new hardware. Now you can buy an iSCSI HBA. You can buy an iSCSI card, and probably for performance reasons you want to do that. But it's not a requirement, it's an option. So if you want to be an iSCSI client right now, you just go and download a driver, and your laptop is also an iSCSI client. iSCSI targets, these are devices that have the controls or have the access to these large storage devices, large storage units, large LUNs. So block data goes through these iSCSI storage devices, these iSCSI targets. Some of the vendors out there, Cisco, EMC, NetApp, HP, IBM, all the big boys in terms of storage, either have an iSCSI solution or are developing one because it's a very exciting technology. It's very cool. If it had more security, I would probably use it a lot more. And it listens on port 3260. So anytime you see port 3260 on your network, that's probably an iSCSI storage device. So again, this listens on any TCP port, just like FTP or Telnet or anything of that sort. So here's an example, a simplistic example of how iSCSI works. On the left side of the screen, you have iSCSI initiators, iSCSI clients. On the right side, you have an iSCSI target, and it's listening on port 3260. And this iSCSI target has 4 LUNs divided up. So what would happen is the clients go ahead and connect to the target on 3260, and by default, the only thing they need to connect and get access to the correct data LUN, to the correct LUN, is the correct initiator node name. Again, the correct MAC address, if you will. So if they have the correct initiator node name, the iSCSI device will say, okay, you give me your initiator node name, I'm going to look at it, and like, oh, okay, so in my internal table, I know that you should get access to LUN number 2. So I'm going to go ahead and give that to you. So what they do is go ahead and present their initiator node name, which is in pink and red, and at that point, the iSCSI target is going to go ahead and present these LUNs over the network to these devices. And the operating system at this point is going to see another drive show up on their operating system. The top one is the local drive, the bottom one is the network drive. And that's basically a simplistic example how iSCSI can work. So here's a kind of a review of that, where the top drive is the internal disk drive, and the bottom one is over the network by the storage device, the iSCSI storage device. So you can see, if you're a storage person, the excitement around this, because it makes a lot of things easier. And notice the operating system doesn't know the difference. The operating system thinks there's another storage device, another hard drive in its operating system in the desktop itself. In fact, it really doesn't care, because all it knows, it has 30 more gigs of data that it can start using immediately. And lastly, with the introduction, simple name servers. So simple name servers can be software-based, so you can load it on your Unix or Windows operating system, or it can be a service on an iSCSI target. More than likely, it's going to be a service on an iSCSI target, but you can download the Windows simple name server and use that on a separate operating system itself. And just like DNS, it allocates, iSCSI, or allocates clients and servers so they can find each other for this purpose on iSCSI networks. This service listens on port 3205. So the 2 ports that you want to keep in mind for iSCSI are port 3260 and port 3205. If you see those on the network, they're probably an iSCSI entity and something that could be open to attack. So here is a simple name server model where a user would actually join and become part of a simple name server group. They go ahead and register with a simple name server, so they just send their IQN, their initiator node name. So the iSCSI target would do the same thing, and they build a table up. So each entity that registers with a simple name server gets put into something called the default domain set, or the domain set, or it's different for every vendor, but basically this one big default group where they put everything in. Because anyone can register with a simple name server. You don't have to be trusted or untrusted. You can just register. Just like DNS, you can plug into the network and start, doing host name lookups and things of that sort. But it can also have a separate exchange domain. So these 2 servers at the bottom are in a separate domain. So the ones in the exchange domain can't necessarily see the things in the default domain, and the default domain definitely can't see things in the exchange domain. So it's basically trust groups, but it's actually logical segmentation of clients and servers, so they don't really kind of step on each other's toes. So at this point, the simple name server is going to tell the iSCSI client on the top left that you are allowed to see this iSCSI target in red, because that's in your domain group. But you're not allowed to see the iSCSI targets in the exchange group because you don't belong to those. So when it queries information, it's going to give information about the iSCSI target that it should have. Here's an example of the exchange groups. Of the discovery domains and the other domains. You have the exchange domain, database domain, discovery domain. Again, just a logical segmentation. Okay, so that's kind of wrapping up my intro part. So now we're going to start talking about the security issues. So hopefully everyone gets a good feel of what iSCSI is. Pretty simplistic. And you're going to see the attacks that I'm talking about are probably even more simplistic. If you're a security person, you're going to be probably saying these are really trivial, and it's amazing that these things actually can happen. And that's the same reaction I had when I started looking at iSCSI. These aren't sophisticated attacks. They're very simplistic attacks. But when you have an attack surface, such as the connectivity of IP, and something that really has not been looked at in terms of security, you have some big problems. So what I'm trying to say is that, you know, the storage companies haven't necessarily had to worry about security, either because people aren't asking for it. I mean, now they are, but for the last 5 years, they kind of been thinking about it, but customers haven't really been understanding that, okay, do I need security on my storage devices? Well, now with iSCSI and now with all the data compliance issues, security and storage is becoming a big, big deal. So what are the top 5 security issues for iSCSI, in my opinion, and only in my opinion probably? One is the initiator node name, the values, the IQ and values are completely trusted. So it's like me trusting, or a network trusting their MAC address and removing usernames and passwords, removing file permissions, removing, you know, anything and anything besides the MAC address. You are now your MAC address, and if you can change your MAC address, well, that sucks. If you can sniff it, that sucks. If you can brute force it, that sucks. And iSCSI, that is completely trusted as a known value that a system is identified as. The second issue is that it's often the only value that's required for security. Now, I will say that you can enable authentication, and we'll get to problems when you actually do enable authentication, but the majority of ones that I've seen, and that's not necessarily an exhaustive search of all storage vendors, but the majority of the time, authorization is the only thing required to get access to large data blocks. And when, so authentication is disabled, but when you do enable authentication, it uses Chap. And it doesn't use a different type of Chap or a different implementation. It uses Chap as we know it. You know, all the security issues with Chap are basically inherited by any iSCSI storage device that's using it pretty much out of the box. And number 5, simple name servers. These groups, or these entities that kind of manage the groups, these domains, are also vulnerable to attacks. They're not protected. And you can play games with the simple name server and get access to domains that you shouldn't have. And so these are my kind of top 10 or top 5. And the surrounding issue is that, you know, iSCSI is a clear text protocol. There is no encryption. Now, you can use encryption like IPsec. But for those of you who were here earlier in Mudge's talk, he talked about a couple interesting things with IPsec, or with encryption. And iSCSI can use IPsec. So 2 years ago, I gave a talk about fiber channel security, and I said, you know, there's no inherent encryption, and that's bad. Well, iSCSI, there is. So someone could say, well, what's the issue? You want security, and now you have IPsec. But if you're a storage person, and a security person goes to the storage person and says, hey, I want you to use IPsec, and you know every call that the Exchange server has to make to its local drive, which is actually over the network, is going to take an extra half second, that storage person is probably going to laugh in your face. They cannot accept performance issues. They cannot accept, you know, capacity issues, and they cannot accept like downtime. So saying to a storage person that the ability to get access to your data is going to be significantly slower because I want you to use IPsec is not going to go over very well. Now, I'm not a performance person, and I'm a capacity planner, so I do not have tons of tests to say that IPsec has no performance penalties, but there's a gentleman at Network Computing that I've talked to, and the performance issues are pretty big. So if you can enable IPsec, that's great. But most times, I've still not seen a storage vendor using iSCSI that has enabled IPsec. And so hopefully I'll be seeing more and more of those, but it's not something you can easily do. It's like one of those great security recommendations on paper. You know, you see it on paper, it's a smart idea, but implementing it is very, very difficult. It's not just simply turn it on and everything just works. Okay, so the first thing we're going to do before we kind of jump in straight to the attacks is talk about enumeration. And the reason why I want to talk about this for just a few moments is because a lot of time I talk about, you know, storage security, you know, fiber channel NAS, iSCSI, and, you know, someone always raises their hand and says, well, isn't it pretty difficult to find these things on the network? I mean, part of the security that a lot of storage people rely on is security by obscurity. You know, people are worried about the Windows operating system or the applications, so they're not going to look at storage, or they're not going to be able to find these storage networks. So we're going to go over 3 methods where you can find these iSCSI targets on your network. Now, there's more than 3, but we're going to just use the top 3 methods to find these iSCSI targets on your network. But moreover, you know, the fact that is using IP, and that IP, once you connect to an internal network, you can find things. Now, another argument you'll hear is that, well, it's on the back-end network. our iSCSI targets are on the back-end network, so no one can get to them. Now, if that's a true statement, then that's a very good thing. If your back-end network is truly segmented, trusted, and isolated, good for you, you're doing the right thing. The fact is that that Visio diagram where you have the web servers, application servers, database servers, and storage, that's great on paper, but that's not how IP works. You can get to anything. It's a switch, right? And switches switch. That's what they're made to do. So you can get access to it. So even though the Visio diagram has things in layers, unless you actually have built a back-end network that's not accessible to the core internal network, you can get to that storage network. These people don't. Question? Yeah, well, that's a good point. If you have VLANs, if you set up a VLAN on the back-end network, so trusted or isolated and segmented, then you're doing the right thing. But if you haven't, just saying that people don't know where they are is not really a security control. Good question, or good point. Okay, so how do you go ahead and enumerate your iSCSI target? Very simple, port scanning. 3205 and 3260. Again, if you see these two ports, it's more than likely an iSCSI target on your storage network. I've written a tool, a very bad port scanner for storage only. It's not better than Nmap. In fact, it's very, very crappy. But I've written it for people, storage people, who don't want to learn Nmap or don't really use port scanners all the time. It's a port scanner that's only going to be showing ports and protocols that storage devices use. So iSCSI, NAS, CIFS, things of that sort. Question? Okay. So the question is there a way to change the port that an iSCSI storage device listens on? In my experience, I have not seen that, but okay, there's a storage, yes you can. So you can. So that'd be another way to do it. I wouldn't use that as a security control though, but yeah, to kind of change the port that you can listen on. But traditionally, the RFC is 3260 and 3205. Do you guys know if you guys can change yours or? No. Nope. Okay, there's a couple other vendors who say no. So some vendors can, some vendors can't. Okay, so again, if you're a storage person who doesn't use port scanners, you can use StoreScan, but what I recommend is using Nmap and looking for these two ports on your network to find your targets. The second method is just registering with a simple name server. Again, the simple name server will accept anyone to register, just like DNS. So you register with a simple name server, and then instantly you will be told all the targets in the domain that you belong to, which will probably be the default domain set if you are a malicious target, if you're just someone that connected to the network. But you're going to be instantly told that, hey, you're an iSCSI client, here are all the targets that you can target. Here are all the targets that you can try attacking. And it gives that information away freely. It doesn't try to keep that. It's not a security tool. It's a logical segmentation tool. And an SNS server is basically giving out information freely. To kind of show that, I'm going to show a quick video. As people say, a picture says 1,000 words. Well, to me, a video is like 10,000 PowerPoint slides. So I have a whole bunch of videos that I like to show. So here's me scanning actually scanning one simple name server instead of the entire network. You can do the Class C or Class B, whatever you want to do. And you're going to see here that port 3205 shows up. So at this point, I'm going to open up my Microsoft iSCSI client. And again, you don't have to use the Microsoft client. You can use any client. So don't pay attention to the UI, because the UI is not important. But you open up an iSCSI client, and basically you register with a simple name server down here at the bottom. So you go ahead and click Add, and type in the IP address that you found listing on port 3205. And then you go to Hidden Targets, and now you can see here are the targets that are on the iSCSI network. So you just found one target. It's pretty much that simple if you're trying to look for a potential target to try to attack. But if you guys were listening closely earlier, what if a storage person or storage administrator said, okay, I know that anyone can register with my simple name server, so I'm not going to put anything trusted in this default domain set. I'm going to get rid of them. and I'm going to put them in the exchange domain or the trusted domain or the Oracle domain. So if you do happen to do that second method to enumerate your target, it's only going to be targets that I don't trust. So have fun with them because I don't care about them. Well, another thing you can just simply do to get around that is do a man-in-the-middle attack against a simple name server. Because it's listing on IP, and it's vulnerable to all the IP attacks, which aren't new attacks, and sniffing on a switch or sniffing on an IP network is nothing new. All you have to do is put yourself in the middle of the simple name server and its clients, and all the traffic will come to you first. And once the traffic comes to you, you can enumerate all the initiator node names of the targets, the clients, basically everything. No matter if they're in a trusted domain or they're in an untrusted domain, the default domain, you have all that information. So at that point, you can just set up your sniffer and collect that information as you would like. So those are the three methods you can enumerate iSCSI targets. Actually, there's more than 3 methods, but that's one of many methods. 3 of them we've shown to enumerate your target. So let's now start talking about the attacks. So again, as I said earlier, the initiator node name is the entity that's required for security. It's the one thing that's required. What is the initiator node name? So let's break it down a little bit more. It's basically made up of 4 different parts: type, date, the reverse domain name of the naming authority, and for the Microsoft one, the host name. If you have a Cisco, IBM, HP, or something else, the last part is going to be different. But the point is, 3 of the 4 things that make up the initiator node name are going to be static values that are known. So think of your MAC address. Every MAC address usually has some vendor-specific part of it, usually the beginning. Same idea with the initiator node name. The 3 first parts are going to be something vendor-specific and are going to be known. The last part is what you have to guess, what you have to brute force. So for Windows, it's pretty easy because it's really easy to get everyone's host name on the Windows network. So you get the host name of your Exchange server, you change your initiator node name to the one that your Exchange server is probably using, and now you are the Exchange server. And that is how simple it can be. Or if you just want to brute force, you can just brute force a key space. Now, it might take you some time, but you can brute force a key space that's not very long because, again, 3 of the 4 things are known and not unknown. But the fact is again, iSCSI is a clear text protocol. So you can just sniff it over the network. You know, if you want to do the hard part in brute force, you can do that, or you can just do the easy part and sniff it over the network, get the initiator node name. And these initiator node names, I don't think I've said this, they're like passwords. They're better than passwords, you know, because they give you access. So you harvest them. You just collect them as you're scanning the network, and these are things you can use to get access to data. Sure.
I think the problem with that notion, though, is that once you have the iSCSI initiator and you actually try to connect to it, if the iSCSI initiator is already connected to a volume, you can't get out.
That's a good point. Save that comment, because I'm going to actually talk about how you're correct, but there's a way where you can just be patient enough and get around that issue. So the comment he made is that iSCSI, or block communication, is different from like file level. Like you can have 2 NFS clients accessing the same NFS file system, or CIFS, or the same sort. But in block format, you can't have 2 clients with the same initiator node name accessing the same data block. You can't have the same hard drive in 2 different machines. So that's the point he's making. But there's a way where you can be patient and actually get around that. But that is a true statement. So we'll just get to that in about 2 seconds. So what we're going to do is sniff the iSCSI communication on port 3260, spoof the initiator node name, and get access to data. So here's the architecture that we're going to set up. You get the trusted client at the top, you get an IP switch, and you get an iSCSI storage device with 2 LUNs, LUN 1 and LUN 2. On the bottom, you have the attacker who's sniffing the network. So the architecture is where the IQN of the trusted machine ends with Win2003-HD, and that is allocated to LUN 1. Very simple. Now, the IQN of the malicious machine ends with Jumanji, and that has allocated nothing. It has no access. So what the user is going to do, or the malicious user, they're going to sniff the network, spoof their initiator node name to the one of their target, and then get access to data and represent this. And as the gentleman just said, at this point, there's 2 clients with the same initiator node name trying to access the same block of data. So what happens instantly is a denial of service attack. So at this point, a denial of service attack is that legitimate exchange server can't access this data, and neither can the attacker. So if you're just trying to get data offline, you've succeeded in doing that. But what if you actually want data? So you can do one of two things. You can be patient, and you can do what most humans do, which is when an exchange server has lost its data, you can look at it and see if you can reboot the server or reinitialize the service. Now, maybe that's not going to happen, but I would say 8 times out of 10, one of the two things are going to happen. At that point, there's only going to be one iSCSI client trying to access that piece of data. And at that point, you will have access, the malicious user will have access to the data. That might be for 5 seconds, 5 minutes, 5 days, but it's probably enough time where enough information, well, not enough, but some information can be compromised in an unauthorized way. That's the passive way, the patient way. If you want to be an aggressive attacker, you would do this attack, and then you would do a denial of service attack against the client. So you take the client offline, get rid of that, and then now you're the only person trying to access that piece of data, LUN1, and that's how you get access. But, as you said earlier, if you have 2 clients always trying to access the same data, it's a denial of service attack, but you never get your data also. So it's not a complete loss, but you're still vulnerable to a denial of service, which, if you talk to any storage person, might not be the best thing also. Question? No, so the question was, are you doing the denial of service attack against a client with iSCSI? The answer is yes. The moment you spoof your initiator node name and you send that, so you're now becoming like the exchange server, and you have someone who is the exchange server, and you're both sending these packets, that's the denial of service. So not in terms of security denial of service, if that makes sense. So yeah, as soon as you do that, you've taken something offline.
Where have you seen it be in denial of service? Which iSCSI product have you seen that happen? Because my experience has been that when we try to do that, because I actually tested that out also, and what happened was it just didn't allow it to go out, just got blocked. But it didn't create a denial of service. The other client, which was the original client, seemed to work fine.
Okay, so in my experience, that's not what I've seen. So we'll talk, yeah. Because what I've seen is as soon as that happens, both machines can't get access to the data.
The client or the client that I'm trying to connect to will hang. It's almost like I lost myself, but
the attacker client.
Yeah, the attacker client.
But the legitimate one, in your experience, doesn't. Okay, that's exactly opposite what I've received. Okay. Question?
Just on that, if you can do layer 2 attacks and pretty much reset the connection back to the client, then you can do a manual attack. If you've got an iSCSI server that's sitting with your malicious iSCSI client, then you can pretty much proxy into the iSCSI request back to the iSCSI storage device anyway, which effectively gives you full access to the block device.
Right, yep. And so what the gentleman just said is that if you have these issues between vendors that you might have a denial of service, if you don't, you could just simply do a layer 2 man-in-the-middle attack and have everything route to yourself. So you don't have to worry about denial of service attacks, you don't have to worry about some vendors being offline, you just redirect everything to yourself and get access, so you're not only layer 2 the identity of the target, but with iSCSI the identity of your target. So both aspects will guarantee you the right to, or guarantee you the access to that data, not definitely the right. Good point. So to kind of show this in real time, let's show a video. Okay, so here's an example attack. And the black screen is the attacker. In a second, I'm going to move over to a blue screen, which is the trusted user. So if we go back for a second, you're going to see 2 screens. This guy here at the bottom is the black operating system, and this one here is the blue operating system. So if we go back, one second. All right, hopefully everyone can see that. Okay, so this is the attacker, and they're just going to open up a sniffer. This is done in a lab environment because you don't want to do this in production data. Let me repeat that. So obviously, I don't need to do a man-in-the-middle attack here, but so I'm sniffing the network on a lab environment. Can't emphasize that enough. Just bring up your favorite sniffer, Ethereal or whatever you want. And now you can see we're sniffing the network, and here's the trusted system, the trusted client. And the trusted client is going to go ahead and connect to its iSCSI target. You can see down there has the initiator node name of Win2003-HD, and that correlates to the host name of the machine, again, which is only default by a Microsoft client, but just showing you how that works. And what we're going to do here is just connect to our target. So we go ahead and connect to our target and log in. And we're instantly connected here. And you're going to see a new drive. This local drive is a local disk drive, and the new volume is the one that's over the network. So we're going to go ahead and open this. Again, we're the legitimate users, so nothing is out of the ordinary at this point. So we're going to open this file called This is a Test, and we're going to add the word test. So we know that this is exactly the file that we're using that's about to be compromised, or the data block, I should say, not the file. Okay. And we're going to go ahead and open our disk management utility. And here is, down here, the one over the network, the disk drive over the network, disk 1, and of course disk 0 is the local one on the operating system itself. Okay, now that I've done that, I'm going to go back to the attacker's machine who's been sniffing the network, and I'm going to open up those iSCSI packets. And you're going to see right there in the clear the initiator node name. Right here that ends with Win2003-HD. So again, what you want is in clear text. So you're going to go ahead and take that and put it into a log file. So if you're actually doing a security test on your storage environment, you'd probably just sniff for a long time and just harvest these out of your log files, your ethereal log files, and just gather these. Go ahead and hit save, or go ahead and save it. You don't need the sniffer anymore. So open up your iSCSI driver. Again, this is the Microsoft one that I happen to use. And before I do anything that, you're going to see only one drive here, the local disk, nothing else. So just remember that as the before. And I'm also going to show you the disk management utility so you can see only one drive. Again, the before shot. So again, one disk. Okay, so now that we have that down, let's go ahead and spoof. So let's go ahead and change our initiator node name. Again, our initiator node name ends with Jumanji because that's what the machine name is. So we go ahead and change that, and you can see there's a change button that allows us to do that nice and easily. So copy the last half, paste it, change, and now we're going to go ahead and connect to that iSCSI target. But now we have spoofed ourselves, so we're in a new identity. We're not Jumanji anymore, we're Win2003-HD, and now we're going to connect to that storage device. So we hit OK, we're connected. Now if we go to the attacker's machine, you see that new volume that wasn't there before. So now we have just taken that entire data block from the iSCSI device, from the iSCSI target, and basically stolen it, hijacked it, compromised it. At this point, we have a denial of service attack, in my experience, that two machines trying to access the same piece of data. So you have two options, actually three options. You can be patient and hope for a reboot. You can do an aggressive denial of service attack, or you can just do a layer 2 man-in-the-middle attack and make sure all the packets go out to you. So you can keep that new volume. So even though you can see it, if I double-click on it, my machine hangs, and when I double-clicked on the legitimate user, their machine hung. So basically, both machines didn't have access to the data. So you do one of three options to get control of the data. In this experience, in this simple lab test, what I did is basically reinitialize the service because it hung, it couldn't get access to its own data. And at that point, you're going to see from the attacker's machine, in just a second here, you hit the new volume, and the attacker's machine, open up that file that we modified, and you can see it's the same file with test, and if you go back to the attacker's machine and open up disk management, in just a second. Oh, I guess I don't, okay. It must have been a different video file. I don't open up disk management, but if I would open up disk management, you would see a second hard drive that the attacker just has access to. So all they did was sniff the network, copy the initiated node name, and got access to, you know, another gig of data that they shouldn't have. So to kind of show that attack again and kind of reinforce that, I'm going to show pretty much the same attack, but with a lot more data. In this example, you have a initiated node name that starts, or that's a Cisco client, and this client has access to LUNs 1 through 5 with the same attack or with a different attacker that has the initiated node name of Win 2003. Again, they're going to sniff the network, spoof their initiated node name, and get access to data. So let me load this one up. Let's see if it's the right one. And I'm going to skip to the part where they spoof their info. Okay, right here. So here is the attacker in a different attack. Disk management, you only see one disk, disk 0. So at this point, they've already sniffed the network. They have initiated node name. They're going to go ahead and open up their Microsoft iSCSI client, change their initiated node name. Just a second here. Well, first they're going to go ahead and type the IP address of their iSCSI target. And at this point, if they log on, actually, this is actually good. I'm going to go ahead and log on. So I've been allowed to connect, but I did not spoof my initiated node name. And you'll notice nothing changes. So even though I was allowed to connect, I have the incorrect initiated node name, so I didn't get access to any data. So I have to go back and spoof my initiated node name. So it's just a simplistic example just to reinforce the fact that you can connect here, but connection doesn't do anything. You must have the correct initiated node name. And this goes back to the statement I said earlier that the initiated node name is a trusted entity. It's a trusted value. It's not something that is just there as a possible identifier. It's the identifier on the iSCSI storage network. So you go ahead and hit change after you changed your initiated node. Hit log on, hit OK. Now you're connected, but now you're connected with a new initiated node name. And now you go with the disk management, and it's going to take a couple seconds here because you're going to have access to more disks than you did before. But you go into disk management, and now with the new initiated node name that you sniffed over the network, you're going to have access to 230 gigs of data without a single password. Skip over that. So at this point, again, you're doing a denial of service attack, but you can delete this data outright if you want to. You can do whatever you want, and you can see these disk drives that were not there are now there now for you to reformat, delete. Now, if you want to read them, again, you have to do one of the 3 attack options, man in the middle, aggressive denial of service, or just waiting out the legitimate user to reboot. But at that point, you're going to have access to those 230 gigs of data. So hopefully. Okay, so one of the things that people do to stay away from these attacks is use domain sets. We talked about domain sets and what they were, but obviously giving people access to data with the initiated node name is a bad idea because it's pretty wide open in my opinion. But so domain sets can be used to kind of segment things so things can't see each other, right? So yes, you can do this, but let's keep our Exchange servers in a different domain so no one can get access to them. Well, the problem is they rely on the initiated node name also. They're relying on an entity that's not trusted, that shouldn't be trusted. So you can do a simple name server domain hopping attack, which is similar to a VLAN hopping attack or a zone hopping attack. You change your initiated node name, you re-register with a simple name server, and then you will become your target. You will become that client that is trusted even though you are the malicious attacker. So in this example, you have a client that registers with a simple name server, and they have the IQN of Win 2003, and you have that's the legitimate user. You have the attacker that registered with the simple name server that has the IQN that ends with ISEC. So what happens is the simple name server creates a table, and it says this unknown entity called ISEC is not trusted, so I'm going to put them in the default domain set. And the 2 entities that I do trust, Win 2003 and the iSCSI target, I am going to put it in a trusted domain, so it's separated. And maybe that iSCSI target has like financial information or source code or something that your company wants to protect. Well, the attacker, all they need to do is change or spoof their initiator node name to Win2003, re-register with a simple name server, and when that happens, the entity, which is pretty much the host name of the attacker, the IQN of the attacker will be Win2003, but the entity that it's recognized as from the simple name server will change from Win2003 to iSEC. So you can see here, down here, the entity changes, and now it's just hopped across domains. But as always, this is easier to show with an example. So here is the simple name server software on this operating system. Again, it doesn't matter that this is a Microsoft software. It's the protocol itself that's the issue. We have a trusted domain called trusted with our two trusted clients. One is the Win2003, and the entity that it's recognized as is the Win2003, and of course the iSCSI target that's also trusted. What we don't trust is the IQN that is called iSEC, which we'll see here in just a second. So this default domain, this catch-all domain, has the malicious user called iSEC. So in a second here, I'm going to bring up the client software of the malicious machine. So for resolution reasons, it's going to be on the bottom of the screen, but it's a different machine that's the host operating system. This is actually our RDP session of a different machine right here. So what we're going to do is bring up the client and spoof our our initiated node name to the trusted value, which is Win2003. So here's the malicious attacker, and you can see their IQN ends with iSEC. And you can see they've registered with the, let me go back here. Actually, forget it. They've registered with the simple name server, and the targets they have access to is none. They have absolutely no access because they're not trusted. So this is a good way so that it's supposed to work. But as soon as they change their initiator node name, they're going to be able to hop across domains. So they go ahead and change it to Win2003, hit OK. Now they're going to have to re-register with a simple name server. So basically, you got to delete this and add it back in. So type in the IP address of your simple name server. So you're re-registering, and at this point, you're going to go back to the simple name server, and notice nothing has changed. But in a second, when I hit refresh, the entity that I'm circling right here is going to change from Win2003, which is the trusted client, to the entity called iSEC, which is the untrusted client. But it's going to be still recognized as the spoofed initiated node name, virtually hopping across domains. And as you can see here, now it's being recognized as the iSEC malicious client. Now, if you go back to the client for further proof, you're going to see that the client now has access to a target that it shouldn't have access to in the beginning, right here. So I showed you before nothing was there, and now that I spoof my initiated node name, I do have access to this trusted client, and now I can perform more attacks. So at this point of the presentation, you should be pretty much convinced that authorization values in iSCSI are not good. I think I beat that point to death. So what about authentication? You should be asking yourself, okay, I understand authorization is not the best thing to do in iSCSI, so I'm going to enable Chap. Am I good then? Well, to some degree, I would still say you're not that much better, because Chap, again, is not a strong authentication protocol. Again, you don't need me to tell you that. It's, again, have been documented multiple times. Now, the testing I've done with iSCSI Chap has not looked too favorable. Three things kind of point out to me. Still, usernames are in the clear. It's vulnerable to offline brute forcing attacks, and it's also vulnerable to message reflection attacks. So we're going to talk about these attacks in depth at this point. So how does Chap work? So some of you probably already know how Chap works, some of you who may not. So let me kind of break that down for just a moment. Again, I'm not a Chap expert, but to my understanding from the iSCSI RFC, this is how it works. So a client is going to request authentication from a target, right? And Chap is okay with sending usernames in clear text. In security, that's still not a good idea, but Chap is okay with doing that. It's not comfortable sending passwords in clear text. So what it's going to do is make an MD5 of the password and send that along. But actually, that's not a smart idea either, because then you're vulnerable to replay attacks, because that MD5 hash of your password is going to be the same. So every English word in the dictionary could have an MD5 hash, and it's going to be a password equivalent. It's not going to be unique. It's not going to be any better than sending the password itself if you just take a hash. So what Chap does is says, well, hey client, don't just send me an MD5 hash of your password. I'm going to send you an ID, a random ID, and a random challenge. So I want you to take your secret, and I want you to take this challenge and ID I gave to you, put everything together, concatenate everything together, and take a hash of that. And you send me that. And every time someone tries to authenticate against me, I'm going to send them a different challenge. So it's never going to be the same hash. And that way, you do not have to send me the password in clear text or a password equivalent. You're sending me something unique. So the target's going to go ahead and say, okay, you want to authenticate? Here's the Chap ID and the Chap challenge, which in our example is 194 in E500370B. So the client's going to say, okay, here's my equation. Here's what I have to do. The ID is 194. The secret, I know the secret, so I'm going to go ahead and put that there, combine that with the challenge, take an MD5 hash, and send it to the target. The target is going to take that hash, and it's going to say, okay, I sent you the ID and the challenge, so I know that. I also know the secret, so I'm going to do the same thing, and if we get the same hash, then I know you have the correct password. But if you don't have the correct password, your hash is going to be different, because everything else I sent you is the same, the ID and the challenge. So if you don't have the correct hash, I know you don't have the right password. So that's basically how it works. So in this example, they have the same hash, they're authenticated. But the attacker here at the bottom is able to sniff 3 of the 4 entities that are required to get the Chap secret, the Chap password, right? So even though we have protected ourselves against a replay attack, we've exposed ourselves to an offline brute forcing attack. So what does that actually mean? So if you put that equation into mathematical terms, think of it this way. What is x if the sum of 1 plus x plus 5 divided by 2 equals 5? Now we could figure that out using math, or we could just brute force it. So we'll start with the number 1. Well, 1 plus 1 plus 5 equals 7, divided by 2 is 3.5. That does not equal 5. What about number 2? Nope, that equals 4. What about number 3? 1 plus 3 plus 5 equals 8. 1 plus 3 plus 5 equals 9, divided by 2 equals 4.5. It's not correct either. What about 4? 1 plus 4 plus 5 equals 10, divided by 2 equals 5 equals 5. So I know that's a very simplistic example, but that's what an offline brute force attack would be. So we use the same idea, the exact same idea, in an offline brute forcing attack of Chap. We've captured the Chap ID in clear text, we've captured the challenge in clear text, and we captured the hash in clear text. So the only thing we don't have is the secret. So if you go to our equation above, we will brute force passwords. We'll start with the word hello, and we'll go through the entire English dictionary until we get a hash that matches the hash that we sniffed over the network. And once we get a hash that matches, we know we have guessed the correct password. Now this might take a long time if you have a strong iSCSI secret, iSCSI Chap secret, and that's a good thing to do. But it won't if you have a common dictionary word. But at some point, this attack can be done pretty much as long as you want it to be executed, because it's not like 3 attempts and you're out, or you only have a certain time. Because it's offline, you can run this attack indefinitely. So what I have done is kind of written a proof of concept tool to kind of go over this with the help of Jesse Burns, who also works for ISEC Partners, to kind of go over this and kind of demonstrate it. So what we're going to do is kind of use that as an example. Whoops. So first thing the tool is going to ask you is, what is the password you want to test? So let's say I want to test the word hello. I think they were using the password of hello. So next thing is saying, okay, you need the Chap ID number. What is the Chap ID number? Again, this is something I sniff over the network. So we've already talked about sniffing quite a bit. So here is another lab environment. Let me put that to full screen. Okay, so here's a connection, a Chap connection that's sniffed over the network. So we're going to go ahead and open that, and you're going to see the initiator node name, but at this point we don't care about the initiator node name because they're using Chap. So, you know, authorization attacks do no good to us. What we do need is the Chap ID and the Chap challenge, which you're going to see right here. Here's the Chap ID, which is 194, and a Chap challenge, which is 500370B. Again, you're just sniffing across in the network. So we're going to go ahead and put that into our tool. 194 is the ID, and the challenge was E500370B. The last thing we need is the hash, which is denoted by the Chap _R value. So we go back to our sniffer, and you can see here is the resulting hash. And by the way, here's the iSCSI username in clear text also, but that's not a big deal at this point. So here's the resulting hash. So I need to go back to my tool and type in the hash that I sniffed over the network, which is C0D74D2BE1226C891E3C2D450160. All right, so here's the hash that I sniffed over the network. So 3 things I sniffed: the ID, the message challenge, and the resulting hash. And I'm going to test the password of hello and see if at the end? Oh, okay, thank you. Thanks. Okay, and you can see that my password is incorrect. The hash that I guessed is not matching the hash that I sniffed. So the password is not hello. So you would try this, and you would go over and over and do this. This tool is a proof of concept. We're going to actually write a tool where we can load the entire dictionary and not do this manually, because that would take forever. But once you basically have access to that tool, which should be very soon, you're going to be able to do something like this. You're going to be able to go down every single word in the English dictionary until you find the hash that matches the hash that you sniffed over the network. And again, as I said before, once the hashes match, you know you have the correct password. So in this example, we got a hash that matched, and our secret turns out to be Scuzzy Security. Now, I want to make sure that it could be 10, or it could be 10,000, or 10,000, or 100,000 attempts. But it really doesn't matter because, again, it's offline. All you have to do is capture one iSCSI authentication session, and you can do this attack, and eventually gets the secret. So to go back to our tool, just to demonstrate this, let's try iSCSI Security. The ID was 194. The challenge was E50370B. The hash I have saved. And at this point, you can see we're told you have the correct password. And that's what the end result would be to the offline dictionary attack. And at this point, you've been able to get into the iSCSI target even though it's enabled authentication because the weakness is with Chap itself. And here's a screenshot of that. Okay, so the last attack that we're going to talk about, I'm doing pretty good on time so far, is the message reflection attack. So this is an attack where you have 2 connections, and you have 2 connections, one's in blue and one's in red. Now you have an attacker, the malicious client, and the iSCSI target. Same scenario as before. People are convinced now that, not enabling authentication on storage devices is bad, so they enable Chap. And, even though people can sniff over the network, maybe this attacker doesn't want to sniff. They want to do something more simple. So what they're going to have to do is a message reflection attack. And what this means is basically opening up 2 connections with the iSCSI target and basically tricking the target to use its own ID and challenge against itself to create the correct hash. And so what does that really mean? So again, an iSCSI client, the malicious client, is going to try to authenticate against the target. So the target's going to say, okay, you want to authenticate, you know the routine, here's the challenge ID, and here's the challenge, and here's the ID. Give me the correct hash after you concatenate this with the real secret. Well, the attacker is going to say, well, I don't know the real secret. That's the whole issue. I don't know the real secret, but here's what I'm going to do. I'm going to open up a second connection, and that second connection, I'm going to try to get you to authenticate against me. Now, this attack, I became familiar with this attack actually when Jesse Burns and actually Sir Distic kind of introduced it in the SMB world, and it's the same concept. And so basically, I'm going to tell the target that I want you to authenticate against me. Now, depending on the vendor, some products will go ahead and say, okay, I didn't ask to authenticate against you, but I will go ahead and do that. Some products won't do that. So it kind of depends on the vendor, the storage vendor. But in this lab environment, if you present a challenge and ID to an iSCSI target, it will respond with saying, okay, I'll go ahead and authenticate. What is the challenge and the ID? So the challenge and ID is going to be what? It's going to be the same challenge and ID from the first connection. So the attacker is going to send the same challenge and ID from the first connection to the target. And the target's going to say, okay, so give me the ID, give me the challenge, and I know the secret, and I'm going to go ahead and put it in my Chap equation here and create the right hash. And I'm going to go ahead and send that hash back to you because, again, I guess I'm supposed to authenticate against you. Now, the attacker has just been given the correct hash to authenticate against the target in the first connection. So it's going to go back to its first connection, and it's going to send the hash that it received from the target in the second connection. And this is the correct hash because you're using the same ID and the same challenge with the correct password. And at this point, the iSCSI client is going to be authenticated to the iSCSI target without knowing the secret with a message reflection attack. Okay, and so I know I'm running out of time, so those are the core iSCSI attacks that I have to talk about. There's two issues, petty issues. They're not even iSCSI issues. So I kind of put them in here only if we'd have time. One is that if you use the Microsoft iSCSI client, it logs things in the clear. The only reason why I put that in there because Event Viewer is accessible over the network via the remote registry service. So if you put in a iSCSI secret that is not long enough, it's logged incorrectly in the log file. So something to keep in mind. And another thing, if you do enable Chap or if you do enable IPsec, it doesn't store it securely in the Microsoft driver. So this is only a Microsoft driver. Why this is important is because if you have enabled authentication, you've probably done it on all your iSCSI clients. Now, if you're a security person, you're probably using unique secrets and unique shared secrets and unique passwords. But if you're a storage person, you might not want to maintain 16 or 17 different passwords. So you might be using one or two. So the thing is, if someone gets access to one of the 17 iSCSI clients and using the same secret, the same Chap's password, then potentially you allow that person to get access to all the Chap clients and virtually all the iSCSI target information that they shouldn't have access to. Again, a very petty problem. It's not a big deal, but something worth noting. So how do you defend against these attacks? Because there are things you can do now to defend against these. And in my opinion, just like everything else, configuration, configuration, configuration. iSCSI, just like everything else on your network, needs to be configured correctly. By default, it's set up to work, to plug and play. It's not set up securely. Just like everything else you've seen out there, routers, switches, operating systems, applications, they're set up to work. They're not necessarily set up securely. So you have to pay attention to your storage devices. They're operating systems, they run on TCP ports, and they have access to data. On most, if not all, the storage devices that I've come across on, there are things you can do to protect against most, if not all, of these attacks. But people don't do it because the education's not out there of why you should do this. So to go over those things, one thing you can do right away is enable mutual authentication. So if you enable mutual authentication, which is, yes, not the easiest thing to do, but if you do that, it will be, your offline brute forcing attack will go away. If you do create multiple discovery domains, it does limit the amount of enumeration someone can do. Now, you can still do domain hopping, but you want to make the attacker do their homework. Just don't give them that information away for free. CRC checksums you can enable. Again, you can enable IPsec where possible. Again, I kind of say that kind of haphazardly because I know that's not an easy thing to do. In fact, that's a very difficult thing to do in an enterprise environment. But number 5 is my most important one. Do not rely on initiated node names. And if you do enable authentication, be aware of Chap attacks and what you can do, like things like mutual authentication to prevent against Chap message reflection attacks or offline brute forcing attacks. Vendors, something better than Chap would be great. Obviously, Kerberos is the ideal mechanism, but Chap, to me, as a security person, is just not strong enough. But more importantly, I'd like to see vendors enable authentication by default, or at least tell their customers that, hey, we have disabled it, but here are reasons why you should enable it if you have anything sensitive on this iSCSI target. And of course, if you read the RFC for the simple name server or for iSCSI, there's a lot of good security suggestions that have been ignored right in the RFC. One for simple name server where you can authenticate heartbeat messages that would prevent against domain hopping attacks. So that's something that would be also very good to see to prevent domain hopping attacks as an option on these simple name servers that you have out there. And that's my last slide. So if you have questions, there's my email address. A very shameful plug for myself is I've written a book on securing storage. Talks about this stuff as well as NAS, CIFS, and Fiber Channel. If you're interested, we can talk later. But at this point, I think I have about 5 minutes for questions. Question?
So, is there a lot of this stuff, I think that you talked about it earlier, but isn't a lot of this stuff mitigated by having a separate data network?
So the question is, okay. So the question is, isn't a lot of this mitigated to having a separate data network? And yes, I would say so. If you have an iSCSI target, iSCSI device, and you've isolated, you've created a separate data network, you have VLANs, you maybe have router ACLs, or maybe even an internal firewall, where your backup network is not part of your internal network, so those 3 enumeration possibilities I showed you would not work, then yes, that's a great way to mitigate it. In my experience, I haven't seen that so much. I've seen customers who've said they wanted to do it, but it's not it talks about re-segmenting your internal network. But
Well, what we've done, just as a clarification, what we've done is a data VLAN. And then we have SISTA, there's a concept called isolated private VLAN.
right.
On top of that, so every client can only talk to the iSCSI target. That's all they can talk.
Right.
There's no way off that.
Yeah, and that's a great suggestion. So if you use private isolated VLANs, basically you plug into a switch, but you're only allowed to see groups within your own VLAN, entities within your own VLAN, you're not going to be able to find the targets. Now, if you've done that, that's a great way to truly segment your network and your iSCSI storage network. However, if your Exchange server, let's say your Exchange server is one of these iSCSI clients, you got to make sure that because the Exchange server has to be accessible to every client on the internal network, that it's obviously not being spoofed from layer 2 attacks or obviously iSCSI attacks using the initiated node name. But yeah, there's tons of IP-centric segmentation things you can do, including ACLs. I mean, these are TCP ports. You know, we know how to segment TCP ports. We know how to filter, but you have to look at iSCSI and apply to these things also. The challenge is they're internal and they could be all over the place, just not, out there on the perimeter. Question? Do all vendors use the same version of Chap? I don't think I really could answer that because I haven't seen all vendors. I've done tests. The tests that I've done, for the major vendors, I would say yes. The major vendors, the offline brute forcing attack, all these things have worked. Actually, if you're interested and you don't have enough, you don't have $200,000 laying around to buy an iSCSI target, there's a free software that you can download called WinTarget. I don't work for them. I don't know these guys, but basically it's an iSCSI target for your Windows operating system, and you can play around with some of these attacks. But to my knowledge, I would say yes, but I can't honestly say yes or no for sure. I think you and then you. Sorry.
So just on that question that's gone back there, unless you're separating each domain into a separate VLAN and having your target sitting on multiple VLANs, you're still going to be vulnerable to layer 2 attacks if you've got different sensitivity of data in those different domains.
Right. So what the gentleman is just saying is that if you even use VLANs, you still have the problem with layer 2 attacks. So layer 2 attacks, I mean, we're not talking about VLAN hopping. We're basically saying that, hey, on the network, using ARP broadcast and ARP pollution, I am who you think I am because you're routing through me. And if you're routing through me, I can get access to that data, maybe not through the iSCSI portion, but again, through the layer 2 attack.
But if you're subject to a layer 2 attack, your problem is not with your storage, your problem is with your switching your routing.
Right.
Bigger problem than that.
I don't know, because yeah, I mean, I think that's open to the comment is that if you have layer 2 attacks, you have different problems, or your problems might not be your targets. And I think that really depends on the organization. In my opinion, and only in my opinion, this is your data. It's a large portion of your data. To me, that would be a priority, as well as everything else. But just because it's iSCSI target does not mean that the switch is more important, because switch is an access entity, right? Where the data is what people are trying to get after, or either delete, compromise, modify, or what have you. Yeah, but yeah, I agree with that statement. So there's other things you have to fix outside of the iSCSI target. But iSCSI, by using IP, is now embracing those, right? It's kind of saying, okay, we're going to use IP, so it can't shy, in my opinion, it can't shy away, like that's not our problem, because it became their problem when they started supporting iSCSI, if that makes sense. Question.
Two quick comments. First of all, on the layer 2 attacks, I can't speak to anything other than Cisco. Cisco, the isolated private relay is set on the port regardless of MAC, so you have to dig into the switch or you just move them back.
Right.
The other thing is, let's say you have this private network. Could you use IPsec without encryption or IPsec through authentication? Does that not be?
Oh, that's a good, so let me see if I got the question correctly. The IPsec, if you can use IPsec without encryption just for the authentication headers, I don't, but I'm not even sure if it's, I mean, maybe one of the vendors can speak up. I'm not sure if authentication headers are only supported with IPsec. Like I know obviously the payload can be encrypted, but I don't know if you have the option, should they only do authentication headers for authentication instead of Chap.
Even then, just turning on AH isn't going to protect the confidentiality of the data, which is obviously going to be an issue here. I mean, if you've got something sitting on the network passively sniffing the blocks, you can take that data. And, for example, say you've got private keys of administrators sitting there, then you can look for those and snap.
Right. No, I mean, that's a good point. I mean, it would be interesting, again, to basically dump Chap and use IPsec for authentication. Again, I have not seen a vendor to actually support that in any manner. And I'm totally out of time, so I apologize. And I guess, thank you everyone, by the way. Thanks for your questions, and I'll be around afterwards. Oh, that's funny.